Okay, so your question now might be, how do we actually tell what goes in a supertype or a subtype? And the answer is going to be generalization and specialization. So generalization is the process of identifying a more general entity type from a set of more specialized entity types. Specialization is the opposite. So it's taking, defining one or more subtypes of the supertype and forming the supertype-subtype relationships. Okay. A lot of words. Let's look at some examples. Okay, so here we have generalization. So our before side, you see we have three different entities. We have cars and trucks and motorcycles. And if you pause for a second and you look at the actual attributes, you see that they have a lot in common, right? Like they all have parts, they all have IDs, they all have makes and models and names and all these little things, but they also have some differences, like cars have a number of passengers, for example. So when you recognize that these different entities share a lot in common, you can oftentimes combine them. And so if you switch them from the before to the after, see that vehicles have all of these attributes in common. And then we split off and see that cars uniquely have the number of passengers, trucks have uniquely the cab type and capacity. But wait, what happened to the motorcycle? Well, before we said that a subtype needs to have a unique attribute. Because motorcycle doesn't, it's actually included in vehicle itself. So if you see the data for a vehicle that does not have a number of passengers, it doesn't have a cab type or capacity, that means it has to be a motorcycle. So simple as that. Motorcycle is completely encapsulated in vehicle. Now, if we added a new attribute to motorcycle, let's say that they have a special column for motorcycle license or whatever. I don't know anything about motorcycles. But if you had some special attribute that's unique to motorcycles, then we'd have to actually add a third subtype for motorcycles and have its own little unique attribute. But for now, it's just contained within. Simple as that. Specialization it's a little harder to see, especially without data. Before I said that if you saw systematic missingness, that'd be a really good hint if you have the data. So if you had all the student data and you saw that a lot of students didn't have dorms, they weren't assigned undergrad graduation dates. Instead, they had information for grad student or the grad student graduation dates. That'd be a good hint. Oh, maybe these are subtypes. You can also use business rules. And so when we're doing an ERD and we don't have the data, that's what we're going to have to do. So here, you can't tell from the before, but you can see in the after that purchased parts have suppliers. Manufactured parts, which would be internally manufacturing a part inside of your own factory, they don't have a supplier. Instead, they have a routing number. So we take a generalized, or we take a regular entity there and we specialize it into manufactured parts and purchased parts. And you see we end up with a bunch of other little entities in there in this process, because you see that there's a many-to-many relationship with that supplier, which means that supplies will actually become an associative entity. And those little crow's feet are going to flip inward like we just talked about in the other lecture. So you actually end up gaining 1, 2, 3, 4 new tables out of this one parts entity as we split this up and make them more precise. Now, why would we want to do that? More tables from a design perspective where we're sitting at can look like it's more complicated, but what we want to do is eliminate missingness inside of our tables. We want our tables to be small and concise, so we're only when we're pulling the data from that table, we're only getting the relevant information, right? Because otherwise, if we didn't care, we just throw everything in Excel, right? And just trudge through the data. But in order to be lean and fast and be able to pull up stuff really quickly and use all the capacity of relation data modeling, we want small tables that don't have a bunch of missingness for no good reason. So this is how we do it.